Yeah. Otherwise, you're just going to get the plain old slides. Yes. Okay. This lesson is on modeling periodic phenomena with trig functions, which is straight out of the Common Core 4th year math, which pre-calc is considered 4th year. I don't know if you guys, you're not all seniors, but this is your 4th kind of high school math. Okay. We're going to talk about sinusoidal or periodic functions. I won't read this all to you, but basically physics uses a lot of this concept. You have things like sound waves and alternating current that are a part of or could be modeled by sinusoidal functions. Here's another one down at the bottom. The hours of daylight on any given day over the course of the year is also periodic. Here we go. This is the first question. It's about a Ferris wheel. Has everybody ridden a Ferris wheel before?
Yeah.
I'm not actually sure I ever have, but I've definitely seen them. I can slow this down. I can make it go the other way, but that's as fast as it goes, I'm sorry to say. Okay. The idea here is that if you watched, say, this red one go around, its height as you timed it would go up and down and up and down as time moved forward. So we're going to sketch it as a sinusoidal function, even though you're not really moving forward. The time is just passing. Do you understand what I'm saying? So if you had your maximum height here, you would come down and then you would go back up, and this is as time passed what would happen. Okay? So let's read the question, figure out what we can put in there. Our goal today is to come up with a sketch of a graph, come up with an equation, type it in our calculator, and then use it to predict some additional values. Okay? It really builds on exactly what we did yesterday, but they just gave us the actual picture. Today we're going to have to sketch the picture first from the information in the word problem. As Rashad rides a Ferris wheel, his distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts turning, his seat is at this bizarre position down here. Not very helpful, okay? But he determines that it takes him 3 seconds and then he's at the top, which is 43 feet above the ground. So what can I put on my graph over here? Now what? What is that little story he said? 3 seconds in, he's at the top, 43 feet above the ground. That's a max, and what's the ordered pair for that max? Okay, so it's 43 here and 3 over. He also determines that he is back at his original position after 8 seconds. So he's gone all the way around and he's back here after 8 seconds. So at 8 seconds, he's at some random position again. But what does that really tell us? The period, right? That's how long it took him to go around once. So he would be back at the maximum at what point in time? 11 seconds. In 8 seconds, but 8 seconds after this. So we'd be at 11:43 over here. All right. We don't know where the minimum is, but if we keep reading, it says the diameter of the wheel is 40 feet. So at his maximum height, he was 43 feet up, but the diameter of the wheel is only 40 feet. What does that tell us? The min is at 3 feet off the ground, which I hope makes sense, right? Not dragging your feet every time you go around. As you approach the bottom of the ride, please lift your feet. All right. Sketch a graph, okay? This is the maximum. He comes down to the minimum, goes back up. I could be pretty happy with that being enough of a graph. Okay? When it's this modeling thing, I'm really only worried about the equation more so than the graph. So you don't have to label 5 ordered pairs on this, okay? We need to come up with the equation. What can you tell me about our graph? Amplitude, period. Okay, cosine. That sounds like a good plan. Let's go with a cosine graph. Vertical shift, phase shift, midline, amplitude. Anybody, anything? How do we find the midline or the amplitude? Either one. Okay, this is a distance of 40, so which one is 20? The amplitude is 20, but the midline is actually at 23. Okay, what are the rules for calculating those if you're all confused and you have funky numbers and you can't figure it out? Average will give you the middle, which is the midline. Add them and divide by 2. Okay. The difference divided by 2 is the amplitude. All right. Amplitude 20 period. What did we decide the period was? We already did that. 8. Vertical shift. The vertical shift is the midline, right? So it was 23. The phase shift is right 3. B, 2 pi over our period of 8, so pi over 4. Okay, so what does that look like when I put it all in here? Okay, when we type it in our calculator, it brings up a parenthesis immediately following cosine. Unless we are going to distribute this and make this 3 pi over 4 back here, we need to put in an extra parenthesis here and close it here. Close, okay? I forgot one of these earlier and it totally messed up the graph because it didn't do this as a vertical shift and I got a mess. Okay. Type that in. What mode do we need to be in? Radians. Yep, that's a big deal. You'll just get a line if you're not in radians mode. Okay. 4,000. That's not this question. Erase. 20. Cosine. Parenthesis. It already brought up. Pi over 4. Don't need extra parentheses around that. It'll be fine. Parenthesis. X minus 3, close, plus 23. Okay, what's an appropriate window? We just drew a sketch. What window did we use? We want, I don't know what I just did. A max and min on our which? That's the Y though, right? The Y max and min need to go at least 3 to 43. I think I'll go 0 to 50. But what about X up here at the top? 0 to out past 11. If you look further in the question, it doesn't go past 11, right? They're looking for the times of here. Boy, it's a short ride. 11 seconds, you're done. You have to get off. I don't know. I think I'll go a little past that. I don't know. I'll go to 20. All right, my favorite thing about these is I can tell if I got it right or not because I know some values. What are some values that should be on my equation? 343. So if I do trace, I could look at the table. I'm just going to do trace because I'm lazy. Trace, enter, I get 43. What else? Trace 11. It's back up at 43. If you wanted to try to figure out where this was, anybody know where that would be? It would be 7, yep, because it's a distance of 8 total, so 4 added to 3 would be 7. At 7, it should be at a minimum, or you could just find the minimum and make sure it was at a minimum height of 3. Everybody's okay. Anybody having trouble with their graph? Everybody got it to work? We rock this calculator stuff all of a sudden. All right. Now, how can we find our height at all these other random things? like 6, 4 1/3, 9, 0. You could go to the table. You could put it in ask mode and type all those in. I'm just going to trace because that's the way I roll. So I'm going to go trace 6, trace 4 1/3, or 4 plus 1/3. Okay, trace 6, I got 8.9. Should we just round? Is it feet? I forgot already. Okay. 4 1/3, I could put in 4.333. I'll be fancy and put 4 plus 1 divided by 3, because it'll let me do that. And I get exactly 33 feet. What else did we have? 9 and 0. Can you guys fill those in? What was 0? What was his height at the beginning, that random spot? 8.86, so about 8.9 feet. So he's about 9 feet up when they actually started the ride. So he must have been one of the last people on, you think? Maybe? I don't know. All right, we good? The next one, maybe, is a spring question. Now this says a weight is attached to the end of a spring, and they drop it, it's bouncing up and down. Okay, its distance from the floor varies sinusoidally with time, and we're gonna worry about that. But if we actually, in physics sometimes it'll say like ignoring friction or something. Okay, this is kind of the same idea. If you actually dropped, would it rebounds to exactly the same heights every time? No, it would eventually slow down, right? That's called dampening, and we're going to work on an equation where it kind of does that next week, where it gets less and less and less. Kind of cool. We're just going to look at a couple examples next week. For today, we're just going to figure out an equation for at least the first period or so. You start a stopwatch. When it reads 0.3 seconds, the weight reaches a height of 60 centimeters above the floor. What's that mean? The height, the maximum is? All right. The next low point is 40 centimeters above the floor, which occurs at 1.8 seconds. So out at 1.8, it's at 40. Is that a period? From the max to a min, is that a period? No. What is it? Half a period. It says your graph will not show a whole period. So this is half a period. If our paper went out far enough, we could continue and draw the rest of it, right? But can we, even by just that little sketch of a half a period, can we come up with an equation that should match it? Okay. Which function do you want to use? Go with cosine again. Okay. Amplitude. Halfway between here and here would be 50, right? And above that goes 10, and below it goes 10. So the amplitude is 10. The vertical shift is up 50. What else do we need? Period? Phase shift would be what? Right, 0.3. Good job. Period? Yeah, we got to be careful here. The period is a little tricky because from 0.3 over to 1.8 is how far? 1.5 seconds, but we said that was only half of the period, right? So if we kept going until it reached its max again, I'm thinking the period is 3 seconds, which makes B 2 pi over 3. All right, who can fill in the rest of this then? What goes in front? 10 in the parenthesis. 0.3, okay? Plus 50. All right, who can type it in the fastest? Not me. All right, what's an appropriate window this time, though? If we just wanted like one period, we didn't have to go out very far for x, right? 0 to, I don't know, 5, 6, 2, 4, 3, somewhere there. 0 to 5 would be plenty to see one period and more. But what is the if I'm going to use trace, what is the next question asking? I have to go out past 17.2. So I did 0 to 20 again, but that does mean it's going to show a lot of periods, okay? What about the y scale, or y? It's got to go up to past 60, okay? And actually, if we redid, we'd probably just do like 40 to 60. I left it 0 to 70. So this really does not resemble my paper. And the reason is my scales are so different, right? I went all the way out to 20 seconds, and this one only went to 2 seconds. So we just need to check some points. If I do trace, what could I check to see that it's right? 0.3. Oh, I'm at 60. That's pretty good news. 1.8. I'm down to 40. At 3.3, if you wanted to find the end of the first period, it should be back up at the maximum. Why was it 3.3 and not 3? The period is 3. Yep, because of the phase shift. It started at 0.3, so 3 units later would be 3.3. All right, can you answer the question then? Predict the height at 17.2, so use your table or just trace to 17.2, or do a ask in the table feature. What was the distance from the floor when you first started the stopwatch? So what's that asking you to do? Yeah, trace at time equals 0. Why am I not recording? How did I stop that? Oh, it's moving. Oh. Yes. I don't know why I thought it wasn't moving. Okay. I'll be all right. The stroke's almost over. Okay. Are we good? Yeah. All right. This is a tidal table. It is showing where the high tides are at different times in New Zealand, just because those are sinusoidal curves, right? We're going to not do one about normal tides. We're going to do a tsunami. Okay. It says a tsunami, commonly called a tidal wave, because it's like a change in tide, is a fast-moving ocean wave caused by an underwater earthquake. First the water goes down from its normal level, then rises an equal distance above its normal level, and finally returns. So it's like a sine graph or a cosine graph, okay? It's sinusoidal. So what do you do if you're sitting out on the end of the pier and you see the water suddenly going down? I run. Yes. Great answer. Okay. If you see the water going down, not up, like a wave, and it's going down a lot, okay, tsunami coming. All right, here we go. What can you tell me about this one? Periods about 15 minutes pose the tsunami with an amplitude of 10 meters. Approaches the pier Honolulu, where the normal depth of the water is 9 meters. Okay, so at time 0, before anything happens, where's our water line at? 9 meters. Okay? What happens? It goes up. Well, it does go up 10 eventually to, the amplitude is 10, so it goes up to 19. But what does it say it does first? So it goes down. How much down? Amplitude at 10 meters means it goes down 10, so we'd hit what? -1, which is weird to think about. If you're sitting on the pier and the water is 9 feet deep and the water recedes to a depth of -1, what would that look like? Yeah, the water would, yeah, you'd see extra sand beyond what we'd normally see, like at low tide, would be out even further. Bunch of starfish laying there, I don't know, okay? Then it goes back up. And you're like, oh, that's cool. But what's not so cool is coming after that, right? It keeps going all the way up to 19 meters, 10 feet over where it was when we started. And what else can you tell me? What's this point out here? 15 minutes. Good job. So again, I'm not really going to be picky about you finding a bunch of ordered pairs as long as you can write the equation correctly. Okay, what can you tell me? Amplitude they gave us was 10. The period they gave us was 15, so B is, good job. What else? What do you want to call this shape? A sign? A negative sign, because then we won't have to do any kind of phase shift, right? Everybody okay with that? Upside down sign? What else? Vertical shift of up 9. We don't need a phase shift, right? We called it a negative sign. So fill it in, type it in. Really could get by with only one set of parentheses this time, I think, because there's no phase shift. It brings up a parenthesis when you type the sign button, so you got to close it at appropriate place. Yes, the stroke is back. You have to have an X. If you forget the X, that'll also give you a straight line. Did you forget the X? No stupid heads in this class. All right, window. My window is not appropriate. 0 to 20 is okay, unless it asks. Yeah, I think 0 to 20 is okay. But what do I need? Wyman has to go beyond -1, so I don't know, -5 to 25, would that work? Oh look, it went down first. That's good news, right? So if I just do a trace 15, make sure I'm at 15.9, seems about right. 0.9. I could do 7.5 just to see. There's the middle. Or I could find the max if I wanted to calculate that it went up high enough. I don't know. Maximum value is indeed at a y value of 19. Okay. Now what? Trace. What is that? I'll tell you story about that when we're not taping. Fill these in, 2, 4, and 12. And what's the minimum depth? -1. Wow, how did we say we would interpret that? What would that really mean you would see? Yeah, extra sand, water receding. We can't decide how to spell that word today. I don't know, might have an extra E in here. Yeah. Sorry, Faisal. Ben is still here. Okay.
Hey, Faisal, I love you.
Don't respond, just ignore it.
All right, one more. This is not a question I would probably ask on a test or quiz, but it would apply to something you might do in physics. The wavelength of a wave is the distance a crest of the wave travels in one period. It is also equal to the distance between two adjacent crests. If a tsunami travels 1,200 kilometers per hour, which is a what? Wavelength, rate, or time? It's a rate. What is its wavelength? We're trying to find this. Well, how much time does it take for our graph to do one of these? 15 minutes. Okay. So the rate is 1,200 kilometers per hour. And we have a time of 15 minutes. I think we got a problem. That's in the next question. We got to do 60 minutes down here and 1 hour up here, and then the hours cancel, and the minutes cancel, and we're left with kilometers, which is a wavelength. How many kilometers are we left with? I don't think so. Well, is that what you meant? 300 kilometers? Yes. So in 15 minutes, the crest of that wave travels 300 kilometers. Okay? 1,200 kilometers an hour. It's coming in fast. Did you get that, Jacob, or did we type something wrong? We're good. 1,200 times 15 divided by 60? Okay. Okay. Next question is about rockets or satellites. We have a problem, Houston, only this is not Houston. This is launching from Cape Canaveral. Okay? Cool. I might ask you a question about that in a minute. Okay? First, we're going to do this. Cape Canaveral, which is not on the equator, goes into orbit. Okay, here it's fired off from here. It goes into orbit, and it goes above the equator, north of the equator, and then it goes the same distance south of the equator. So its distance from the equator is a sinusoidal function of time. 10 minutes after it leaves Cape Canaveral, it reaches its furthest distance north, 400 kilometers. What do you want to do there? 4,000 kilometers. I can read. So the max is at 4,000 kilometers north of the equator. And what time does that occur? 10 minutes into its flight. Okay. It reaches half a cycle later. It reaches its furthest distance south, 4,000 kilometers. Where are we going to put that? At negative 4,000 and call that south. Will that work? And half a cycle was how long? Do we know that? Oh, completes an orbit in 90 minutes. Okay, half a cycle would be 45. Does that where that ordered pair is though? Yeah, because this is 45 is half a cycle, and then another takes a whole period is 90 minutes. It says, yeah, those look even. Not. So from 10, if we add 90, we get 100. We good? Okay, so the actual sketch of the graph here, its maximum was here, yes? Returned there 90 minutes later, and sometime in the middle it was at its minimum. So this is at 10, 4,000. This is actually at 55. We decided negative 4,000, and 100, it's back at 4,000. All right. Why don't you guys try writing the equation this time? We can pass the equator. Haha. Sine, cosine.
Cosine.
B. Period is 90 minutes, so you could put 2 pi over 90 or pi over 45. Phase shift, any? Vertical shift?
No, there's no vertical shift.
It goes 4,000 above and below, so the midline is at 0, right? Which you don't have to put in your calculator. Okay, let's see how we did. Wrong thing. Gonna need a window change, I'm thinking. These are bigger numbers than any of our other questions. So Ben, part of my question is there a town at Cape Canaveral?
Yeah.
Okay, that's half my question. I'll give you the other half in a minute. Window, 0 to, does it ask any question? Oh, it does ask a question about 163, right? So I'm going to go 0 to like 170 for my time. And I need bigger than negative 4,000, right?
4,500 works pretty good.
4,500 and positive 4,500. All right, what's an ordered pair I could trace and find? Should be at 1045. Wahaha, 10 what? 10, 4,000. 55, it should be at negative 4,000. And 100, it should be back up at 4,000. All right, find those three values that they wanted for estimating time here. 25. Uh-oh. If it's positive, what are you going to write? What's the label?
North.
It is north, and it's kilometers, isn't it?
Yeah.
What's the second one that I can't see?
41.
If I type 41, I get negative. So that would be south. I'm going to put the negative, but just in parentheses, and write 2237 kilometers south of the equator. And then you can do the last one. All right. If we use our equation to predict how far Cape Canaveral is north of the equator, what do we get? So when the rocket was launched at time 0, we get 3,064 kilometers north. All right. I went online and looked and found a website that said Cape Canaveral is actually 3,154 north of the equator. But that was like the town of Cape Canaveral. And my joke of the day is I highly doubt they fired the rocket off in the middle of the city square, okay? Ben is agreeing with me that it's outside of town a little bit, okay?
You have to be a certain radius away from the launching
Right.
area or else you can pull your ears.
Cool. Yes.
No, it's
Yes.
really tense. And it impacts the tree.
I'm thinking if they set it off in the middle of the town square that they might break a window or two, maybe. We'll just leave it at that. Okay. Should we do a ticket out the door or should we go to homework questions? Okay. Just because your homework is on applications of this, tonight's homework, not the questions you have on last night's. These are some other things that are sinusoidal, okay? The height as time goes by of a pendulum, because it goes up and down, so the height goes up and down. The height of a child on a swing, a sound wave, the pressure inside a blood vessel with your heartbeat, okay? The pressure goes up and down, up and down, up and down. The depth of a dolphin as it dives and jumps above the water. The distance, okay, if you put your little sister on the merry-go-round and spin her real fast, she gets further away, closer, closer. So you, he probably only gets further away. All right. There's also one somewhere, I don't know if it's on this or if it's on a quiz somewhere, there's a question about somebody times their fishing bobber going up and down, up and down, up and down. So that's a pretty exciting story. All right. Homework questions. Maybe I'll let it record. What homework questions do you have? Worksheet 10, usually somebody has a few questions. On the green worksheet?
What do you want?
What is it called?
That's horrible. How forward?
Yeah.
Here, caramel apple, Laffy Taffy.
All right. I'm not finding the better version. I know I have some of it here. What is the question? Are the numbers the same, or do I have? Is this your number 15? No? Okay, tell me what yours says. I don't have it, apparently. All right, guys. Shh. This is off the green sheet, okay? I'm hoping some of you also have questions off last night's worksheet 10 if you had questions. All right, I always start with the midline. Where's the midline on this one? Does it not have this up to? So it's a vertical shift of up to. If you can you can rename and use that as, yeah, the line y equals 2. Okay. This is the green worksheet. That is due on the homework check. Okay. Amplitude is just 1, so it only goes down to 1. Oh, that's a nice straight line. And up to 3. There is a phase shift, what? To the right, pi over 4. Everybody okay? What is the period? Okay, the period is 4 pi. Do you remember the rule about what we count by? You take the period and you divide it by 4, quarter points, 4. So we're going to add pi, and that's how far until we do the next point. So we're adding pi. So 1, if we make that a common denominator, be 4/4 would be 1. So 1 plus 4/4, the next point we need to label will be at 5/4. I can talk. If we add 4 more, we'll be at 9 pi over 4. 4 more will be at 13 pi over 4, and that's the 5 we need, right? Because there's actually 4, 1 on either end is 5. Cosine means we start at maximum, midline, minimum. I didn't do enough, did I? I gotta do one more. So it goes back to its maximum. I'll let you figure out that last one. I think it's 17. Is that good enough? Yes. Yes. Did anybody have a question on worksheet 10? Nobody had a question on, I'll tell you the one I'm looking for. Did we do this yesterday? Did we talk about how to figure out a period for this number 10 or number 14? Okay. On number 14, let me just do this. From the left end, which is at negative 5 pi, guys, please be quiet while I finish this, please. From negative 5 pi to 5 pi, it did 1, 2 and a half periods. Does everybody see that? So what is the distance from negative 5 pi to 5 pi? Over the course of 10 pi, it did 2.5 repetitions or periods. So if I divide that, I get what? Yes, the period is 4 pi. Now, most of us aren't going to look at that as a sine graph, even though the left side kind of started at a sine position, because here's a maximum, right? So here it should finish. Could that be reasonable to say that was 4 pi? Okay, so you can finish the question now? Anybody stuck on any of the rest of that? What about this crazy daisy one? What is, I thought this was a 6, and so I used 6 to explain it in the last class. I'm like, yeah, they said, after I did the whole question, they said, Ms. Hoffbauer, after 3 usually comes 4. All right, so count with me. How many repetitions? 1 to here. 2, 3, 4, 5, 6, 7, 8. So a period, a distance of 4 has 8 repetitions, which would make the period 1/2. Does that seem okay? Finish the first sine graph by 1/2. All right. Anything else? Bye, Faisal.